Assalamu alaikum. Hello guys. We are going to discuss about the electromagnetism. Electromagnetism basically our basic topic. Electromagnetism is basically divided into three subcategories which are known as electrostatic, magnetism and electromagnetic waves. So the short definitions are given of these three types. Electrostatic is the define as very shortly. It is a very short definition, is not exact definition which you will write in your examination. And the electrostatic, very shortly we can conclude that the electrostatic is that charges are at rest. It means those applications in which charges are at rest, we will solve this with the method of the electrostatics. And the magnetism, charges are moving with constant speed. Magnetism, the basic difference between magnetism and electrostatic is that the charges are at rest and charges are moving. When we are going on electromagnetic waves, when in electromagnetic waves charges are accelerating. So our basic concentration is on electrostatics. So electrostatic is defined as the study of electric charges at rest under the action of electric force is called electrostatic. So basic concentration in our topic, that is electrostatic, these are charges. So first of all we should have to know some basic properties of the charge which will be used in our further topics. So electrostatic, before discussing more about the electrostatic, we will discuss about the application properties of the charge. So what are the actually properties of the charge? There are basic some properties which we will discuss in a very fast way. So unit of the charge, that is Coulomb, represented by the C. Actually, first of all, charge were discovered by the scientist Coulomb, and the charge unit of the name was named by that scientist, which is Coulomb, represented by the C. So basically there are two types of the charges named as positive charges and negative charges. Positive charges are known as proton and the negative charges are known as electrons. So there is no third one type. Some students are confused that there is another type of charge which is known as the neutral. So it is a very wrong concept. Neutral charges having no type. This is I don't think I should have to explain it more. So smallest, what is the smallest unit of the charge? That is electron. The smallest unit of the charge is electron. It means actually we have in our further researches we have very small unit of the charges which are smaller than the charges, but at 12th standard it is not necessary to know about those charges. So here we are going to just remember that the smallest unit of the charge is electron. So what is the mode of the electron? Mode of the electron, that is equal to plus minus 1.6 times 10 power minus 19 Coulomb, right? So mode of the electron is equal to 1.6 times 10 raised power minus 19 Coulomb. And do we know about the mass of the electron? So mass of the electron is 9.1 times 10 raised power minus 31 kilogram. And same as we have the mass of the proton, 1.6 times 10 raised power minus 27 kilogram, which is approximately equal to the mass of the neutron. It means we can say that the mass of the proton is approximately equal to the mass of the neutron. And this is a basic property of the charge. When same charges, here I take just positive charges, positive and positive charges will repel each other, and if we take here negative and negative charges, both of these two same charges will also repel to each other. If we take opposite charges, mean I take a negative charge Q1 and a positive charge Q2, so these unlike charges will attract each other. We can see it in this figure. So after this we have another type of the property of the charge, which is quantization of the charge. So what is actually the quantization of the charge? Quantization of charge mean if I have these two atoms, I take this atom number 1 and I named as this atom number 2. So both of the, I take 100 electrons from atom number 1 to the atom number 2. So is that this atom takes positive 100 electron charge and the second atom number 2 takes negative 100 electron charge. Basically, electrons can transfer but protons cannot be transferred. We can have this idea from the structure of the atom. This is the nucleus having proton and neutron, and outer shells, the orbits are shells having electrons. So electrons can easily ejected from the atom, but protons are present inside the nucleus. As we know that the nucleus is the heaviest part of an atom. The most of the mass of the electron is consist of the nucleus. Therefore, the electrons are those charges who can easily ejected from the atom. So one atom, two atom, three atom, four atom, up to 100, 200, up to and so on. We can just only share atoms in integer form. If I say that I'm going to share 3.5 electrons from one atom to another atom, this is false, because it is not possible due to that fact that electrons cannot be divided into further more parts, right? So, and if I say that I'm going to share 4.6 electron from atom number 1 to the atom number 2, so it is also a wrong question and answer. So in further detail, we can say that the charges can only an integer multiple of electron. Then we can write it as it means 100 electron, 200 electron, 500, 1000 electron, 2, 5 and so on. And atoms can share from electrons can share from one atom to another atom in only integer form. So I concluded that Q is equal to plus minus n. N is the integer form, which is equal to the 1, 2, 3 and so on. So last, and then this is the next one, property of the charge, which is conservation of the charge. Conservation of charge, I just made a circle. In this I'm going to take three charges. These three charges. Charge number 1 having a 4 Coulomb charge. First of all, I'm going to discuss about the charges which are written with the blue color. So 4 Coulomb charge, atom number 2 having 3 Coulomb charge, and atom number 3 having 2 Coulomb charge. So after some time, after it means if we say that these charges which are written with the blue pen are initial charges, so final charges will be 2 Coulomb, 6 Coulomb, and the third one atom will have minus 3 Coulomb. So what did I say? That because initial charges should be equal to the final charges within an isolated system. So this property of the charge is known as the conservation of charge. Charges is conserved within an isolated system. Charge is conserved within an isolated system. So next we are going to discuss about the Coulombs law, which is very important law in electrostatics. In electrostatics, when we discuss about the Coulombs law, we take 2 point charges named as Q1 and Q2. If both of these positive charges, then these charges will repel each other. If both of these two charges Q1 and Q2 are negative charges, then they will repel each other again. And if we take positive point charge Q1 as a positive charge and point charge Q2 as a negative charge, then they will attract each other. If I take point Q1 as a negative charge and point Q2 as a positive charge, then they will attract each other. In this fact, we can say that the electric forces between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Here I represented the distance between these 2 point charges with the r. So by concluding, after the statement of the Coulombs law, we can write that the force of attraction or repulsion between these two charges is directly proportional to the product of the magnitude of these two charges and inversely proportional to the square of the distance. There r is the distance between these two charges, so force is the inversely proportional to the square of the distance between these two charges. So if I say that this is equation number 1 and this is equation number 2, for combining equation number 1 and 2, we can have that F proportional to the force proportional to the Q1 Q2 by R square, and F proportional to the Q1 Q2 by R square. So by eliminating this sign of proportionality, we can have equal sign, and there is a constant, that is Q1 Q2 over R square. Here K is the constant of the proportionality, which is sometimes known as the electrostatic constant. This is a K. In we say that in the Newton's second law of motion, we say that F is equal to ma. In this calculation driving this equation, we take a constant K, right? So at this stage we say that the value of the K is equal to 1 according to the SI system, but that was a particular system, that was a particular reasoning. Therefore we say that the value of the K is equal to 1, but here we can say that the K is equal to 1 because K is depending on the nature, because the value of the K depends upon the nature of the medium between the charges and the system of the units. What kind of the system of the units we are going to discuss, and what is the medium. K totally depending on the medium. So therefore we can take the value of the K is equal to 1. So we can say that the value of the K is equal to 1 over 4 pi epsilon, because it is a constant and it is experimentally proved. It is not my own words that I am saying that K is equal to 1 over 4 pi epsilon naught, where epsilon naught is known as permittivity of free space, where what is epsilon naught? Epsilon naught is the permittivity of the free space, and its value is, so what is the value of the epsilon naught? Epsilon naught is equal to the 8.85 times 10 to the power minus 12 Coulomb square per Newton per meter square. So putting the value of epsilon naught in the K, that K, we know that the K is equal to 1 over 4 pi epsilon naught. So for the pi having value 3.14 times the value of epsilon naught 8.85 times 10 to the power minus 12. By calculating these values, we can have the value of the K, that is equal to 9 times 10 to the power 9 Newton meter square per Coulomb square. So sometimes we are asked to calculate the unit of the constant K. So it is very easy to calculate the unit of K. Here we can see that 1 over 4 is the constant, pi is also a constant, so 1 divided by Newton. Here we can say that the Coulomb square per Newton and per meter square. So if we take these up of this up above, then we can write that Newton meter square and per Coulomb square. So this is the unit of the K. We can calculate from by using the unit of the epsilon naught, right? So the electric force between the charges F is equal to 1 over 4 pi epsilon naught Q1 Q2 by R square. We just put the value of the K in this equation, right? So what is the vector form of the Coulomb's law? What is the vector form of the Coulomb's law? So Coulomb's law is the mutual force. What did I say? That Coulomb's law is mutual force. It means that if Q1 exerts a force on Q2, then Q2 also exerts an equal and opposite force on Q1. So I take just these 2 point charges. This is Q1 and Q2. Q1 and Q2, both of these same charges, mean both of these are positive charges or negative charges. Then Q1 exert a force on Q2 in this way. So we can say that the force F21 is force exerted on charge Q2 by charge Q1. So this force is known as a force F21, and later on Q1 and Q2, and now Q2 charge is also exerting a force on charge Q1 in the opposite direction, which is known as the force F12, and F12, that is the force exerted by the charge Q1 on by Q2. So I write these two things over here. these two things means this is unit vector r cap, where r cap in first 11th standard we have studied about these unit vectors. The unit vector having magnitude only 1 and the direction in the same in the vector direction. So both of these unit vectors, when these two unit vectors having magnitude 1 and direction is the opposite to each other, then we can say that f21 is equal to 1 over 4 pi epsilon naught q1 q2 over r square. This actually this is when we write that equation, f is equal to 1 over 4 pi epsilon naught q1 q2 by r square. So this is a simple force. We can say that is the force when we are calculating in scalar quantities, but we know that force is a vector quantity. But when we write a force in a vector quantity, then here is a unit vector present with this force, that is r cap 21. So, and second equation, the force exerted by the charge 2 on charge 1. So this is the force, f21 is equal to 1 over 4 pi epsilon naught q1 q2 by r square into r12 unit vector. So I just named these two equations as equation number 1 and equation number 2. So r21 unit vector directed from q1 to q2 and r12 unit vector directed from q2 to q1. From figure we get both the unit vectors having same where is the figure from where we get these two. From figure we get these two charges are, from figure both the unit vectors having some magnitude. The magnitude, which is I have already told you, magnitude is equal to 1 but opposite in direction. So we can write that r21 is equal to minus r12, right? r21 unit vector is equal to the minus r12 unit vector. Hence equation number 1 will becomes here equation number 1 having the value r21 unit vector. I just replace that r21 into r12 because r21 is equal to r12. So we can write as f12 is equal to, I just take this minus sign from here and 1 over 4 pi epsilon naught q1 q2 r square. So r12, I just name this equation number as equation number 3. From equation number 2 and equation number 3, both of these two equations are equal to each other. So we can write that f21 vector form of the force is equal to the minus this minus sign and all of this area is equal to the f12. So f21 is equal to f minus f12. Thus we can conclude that the Coulombs law is known as the Coulombs law is accordance with Newton's third law of motion, which is the every action has a reaction but in opposite direction. Thank you very much for watching this video. Please subscribe the channel for watching more such kind of interesting videos.